Okay, so we'll continue. Now you have seen different kinematic pairs and everything. You understood how the kinematic pair will be there. So let us understand about constant motion. Okay, so a constant motion in a kinematic pair, if one element has got only one definite motion relative to another, then the motion is called constant motion. Okay, so it is means if you give some a kinematic pair, that if you give some motion passing from one part to another. Okay, so for example, you take example of sliding pair only. Okay, so if you slide on that surface, automatically you are passing the motion, and if you get only one definite motion related to another, then it is known as a constant motion. So a two parts should be having relative motion in contact, and when it is achieved, then only it was known as constant motion. Sometimes what happens, the two bodies are in contact, but there is no motion at all. It is only kept. That is not nothing but is not considered as motion. Constant motion will be only when there is a definite relative motion between two materials. For example, if you keep the book in your hand only and you just keep it as it is, so it is not having any motion. But only when you should take a book and slide on your hand, then only you will tell it is having the sliding motion, and that motion is having relative of your hand with respect to your book. Then there is a relative motion between your hand and book. Same way in the figure you can see there is a sliding pair in the first, and as well as also there is one more revolute pair also. So in this case there are again three types of constant motion possible. If it is a completely constant motion, then if the constant motion is achieved by the pairing elements themselves, then it is known as completely constant motion. So in the figure below, two figures you have seen, the sliding pair and as a turning pair both. What you can see in that, the constant motion is achieved by the pairing element themselves, means you are not applying any other external forces. Automatically the pairing elements only, they are achieving the motion. This is known as completely constant motion. Okay. Next, if you see the next second one, successfully constant motion. So you can see the figure. Yes, a footstep bearing is there in the figure, where the load is applied at the top on the shaft. You can see there, and with that footstep bearing, where the shaft is constant from moving upwards, that is by self weight. Okay. So in this case, if the constant motion is not achieved by the pairing element themselves, but by some other means, then it is called successfully constant motion. So you can see why it is called successfully constant motion, because there is a load applied there at the top. In the last one, if you compare successfully and completely, in the completely by itself it is taking the pairing, means there is no external force provided. Whereas in this case, due to the self weight of the moving by the shaft, you can see self weight, the load, automatically there is a constant. So this is known as successfully constant motion when the force is applied at here, and you can't by self weights only it is having the load. Okay, so this is known as successfully constant motion. Then third one, it is incompletely constant motion. Okay, that is the example. You can see the example of a shaft in a circular hole. Okay, so if you apply a shaft in a circular hole, what happens? The relative motion between the pairing elements takes place in more than one direction. Okay, because if you give this shaft like this automatically, so it can rotate, like in just translate, you can rotate, you can't predict anything. So there are more than one direction possible. You can move in translation also, it can move rotation of the shaft also. So you can't predict. So in this case it is known as incompletely constant motion. So these three, one is completely constant motion, then successfully constant motion, and incompletely constant motion. So what happens if you compare all these three? Completely will have self, only it will be pairing without any force. In successfully, the force will be there at that self weight will be considered in, for example, footstep bearing, and in incompletely the more than one direction is possible, then you can't predict only. That's why it is known as incomplete constant motion. So these are the three things. So next we'll go with the kinematic analysis and kinematic synthesis. So kinematic analysis is nothing but in a given mechanism, the task is determine the various relative motion that can take place in a mechanism. So in kinematic analysis, you are just understanding the relative motion between the two parts which is going to have the mechanism, And then in kinematic synthesis, you are discussing that one has to come up with the design of mechanism to generate the prescribed required relative motion characteristics. Means in kinematic synthesis, you are going to synthesize or you have to design the mechanism. Okay, so you are going to study kinematic analysis in this subject, whereas the kinetic synthesis you will be not studying in this subject. Actually, you have one elective naming with kinematic synthesis of mechanism. So in synthesis of mechanism, you are going to design the mechanism that will be there in the 7th semester. That is an elective. So where you are going to study the synthesis of mechanism, and there you can create your own mechanism by designing. But now we are taking a mechanism directly and you are analyzing that relative motion on that mechanism. So this becomes analysis. So synthesis means creating or designing the mechanism, or where in kinematic analysis you are going to solve the problem now. So in this subject you are going to do the kinematic analysis only, that is solving the mechanism problems. So in this figure you can see kinematic chain is a group of links either joined together or arranged in a manner that permits them to move relative to another. So in the figure you can see this is a locked chain. You can see the locked chain. So here 1, 2, 3 all having a locked chain because it can't move only. So whenever the link can't move, it becomes a structure or a locked chain. Whereas in mechanism, what happens? A mechanism is a constrained kinematic chain, where this means that the motion of any one link in the kinematic chain will give a definite and predictable motion relative to each other. Okay, so you can see there are two examples of mechanism. One is the slider crank mechanism and another is the 4-bar mechanism. Okay, so for your syllabus you will be studying only these two mechanisms, that is one is slider crank mechanism, another is the 4-bar mechanism. Okay, so this one is the first figure is the slider crank and another is the 4-bar mechanism. Okay, so studying the mechanism is very important because each mechanism will be connected to form number of mechanism to run a machine. Okay, so number of mechanisms are created in a machine, then you will get some output in the machine. Then if a particular position of a link of the chain, the position of each of the other links of the chain cannot be predicted, then it is known as unconstrained kinematic chain and it is not a mechanism. Okay, you can see in this figure what happens. 1, 2, 3 and 4 and 5 are connected, and whereas the point which is shown there, that is between 3 and 4, we can't give a particular position. Okay, it can move any place. It can move from this point to this point, or this point to this point, and or this point to this point, and also this can translate the slider in the point 5 with any position. Okay, so it can achieve anything. So it can't predict it. So that's why it is known as unconstrained kinematic chain, and this is not a mechanism. Okay, kinematic chain, you can see the difference between kinematic chain and a mechanism here. So successfully constrained mechanism this is a kinematic chain with a completely constrained mechanism. Whereas here in this you can't predict it. You can see any position can be maintained. If you just put it over here, the 3 and 4, any point can be traced out from this. Okay. Whereas in this mechanisms, here are two examples shown here, it will move with the only specified part. So 2 is going to rotate from here, and 3 is going to here oscillate, and again 4 is going to have the translation motion. Whereas here 2 and 4 is having the rotary motions. Okay, so this is regarding the mechanism. Then how it is different from machine? Okay, so a machine is a mechanism or a collection of mechanism which transmit force from the source of power to the resistance to be overcome, to be overcome. Okay, so though all machines are mechanism, all mechanisms are not machines. Okay, so because machines will have mechanisms, but all mechanisms may not be machine, because machine should have the proper output. A machine will be said to be a machine only when it is going to operate, but a mechanism does not have any particular source. It will just give some linkages and it will just have the motion. For example, you can see example, many instruments are mechanism but not machines, because they do not do some useful work, or not they can go for transformation of energy. For example, a mechanical clock or a drafter. Okay, so this is just a type of normal machine, not a type of a particular mechanism. Okay, so just we'll go with the differences. I'll just go to directly difference. You can see what is the difference between a machine and a mechanism. Okay, so a machine modifies the mechanical work, whereas the mechanism transmits and modifies the motion. Okay, and a machine is a practical development of any mechanism, whereas a mechanism is a part of a machine. Okay, so in machine you can see a lot of mechanisms are connected to form the machine. So mechanism will be a part of machine only, whereas a machine is a practical development of any mechanism. It can have a number of machine will have number of mechanisms involved in it, and a machine may have number of mechanisms for transmitting mechanical work or power, whereas in mechanism is the skeleton outline of the machine to produce motion between various links. Okay, so machine example: lathe machine, shaper machine, steam engine. There's a lot of machines. Mechanism is nothing but a clockwork, typewriter, then PV diagrams and all. Whatever you go for the mechanism, any linkages are connected. You have seen there, so that becomes a mechanism. Okay, so next planar mechanism, I think already we discussed in the morning. Okay, inversions will study later, next part. Okay, so okay, machine we discussed now, and the structure also will discuss. Okay, so what is the difference between machine and a structure? So structure will what will happen? The structure will be completely fixed one, means there will not be any relative motion between the links. It will be completely locked one. So locked chain or a structure is the where all the links will be completely fixed. So can you say, you can see the example of a bridge. Okay, bridge will not move, right? So all bridges you can see there are a lot of links connected in a bridge. Okay, in a, if you go by train, you can see lot of bridges come. They all are nothing but having the steel structures. Everything is built up with heavy structures. They are not having any motion. They are completely constrained. So there is no structure. And in your mechanical labs, you can see at the top, it is mounted by trusses. Okay, so where you can see all that they are completely joined. They are not having any motion, but there are number of links connected together. Okay, but they don't perform any motion. So that's why they don't become a kinematic chain. It is completely locked chain, and that doesn't have the position of motion. That becomes a mechanism. Okay, so what is the difference between now a machine and a structure? In machine, what will happen? The relative motion exists between the parts, whereas in structure there is no relative motion existing between the members. It will have completely locked chain. Okay, and in links are meant to transmit motion and power in machine, whereas in structure what will happen? The members of structure transmit only the forces. For example, in truss and bridges, they are having only force. They don't have any motion. Then in machine, it is meant only for transmitting useful energy to do some certain type of work, whereas in structure no useful energy is transmitted by it. It is only the having the structure stability. Like you can see railway bridges, frames, etc. Roof top you have seen, they are maintained. So they are structures. Machine you have seen the lathe machines, shaper machine and all. They are nothing but machines. Okay, so this is regarding a machine and a structure. Okay, so next we'll not go beyond this. This degree of freedom will come do in the next class. So we'll just discuss about the same thing about the mechanisms. I'll just stop presenting.